when they don't fit the mold of the patterns that we studied first. So the first thing to do is look at the polynomial and make sure it's in what we call standard form. Arrange it so that it's in the form of highest power first. It's easier just to do it in decreasing order. Put the highest power first. And we're going to just call this algorithm, it's an algorithm for factoring quadratic polynomials. And the quadratic polynomial is the degree 2. So put it in decreasing order, meaning highest power first, and then on down the line. So I've given you a problem in your notes. And let's take this problem and arrange it in the correct order. So it would be lined up as 8x squared plus 14x plus 3. So put it in order. And then the next thing you need to do is identify A, B, and C. So A is 8, B is 14, and C is 3. If you don't have the polynomial arranged in standard form, then you cannot properly identify A, B, and C, and then the algorithm that we're going to learn does not work. Step number, well, after you do that, after you get it arranged, after you identify A, B, and C, you take the product of A and C. So that means I take 8 times 3 to give me 24. I'm now looking for factors of the product AC that sum to B. So I need factors of 24, meaning numbers I multiply to get 24. And when I add these numbers together in this problem, I am looking for numbers that add to 14. So I need factors of 24 that sum to 14. So 24 is 12 times 2. 12 plus 2 equals 14. So the factors that I'm looking for are 12 and 2. And this is one of the key pieces. This is one of the most important things to learn when you're factoring quadratics. You're looking for factors that give you the product of AC, two numbers you multiply to get that, but when you add those two numbers together, you have to get the linear term. There are several different numbers, 6 and 4, 8 and 3, but when I add 6 plus 4, I get 10. When I add 8 plus 3, I get 11. 1 and 24, but when I add 1 plus 24, I get 25. So the magic pair that I'm looking for are 12 and 2. And the reason I know I've selected the correct ones, I go back and I look at B. B is 14. So I need 12 and 2. So that's a very important skill along the way to understanding how to do this. So I've chosen 12 and 2 as my factors, and now I need to rewrite the original polynomial with 4 terms. So my original polynomial was this. I am now going to rewrite this linear term as the sum of 12x plus 2x. So I haven't changed anything. I've just simply expanded the linear term, and I've written it as the sum of 12 and 2. And I've chosen 12x and 2x because those were the factors that I agreed on earlier as being the correct factors to fit into the algorithm. And then what you do is something that's called factor by grouping. And when you have it arranged like this, just group 2 pairs together, just keep the order the same. Put parentheses around the first 2 terms and parentheses around term 3 and term 4. Then you look at each set of parentheses and you remove the common factor that they have. So the first set of parentheses, I have a 4 common to each term and an x common to each term. And then what would remain inside would be 2x plus 3. I look at the second binomial pairing that I've created. They both share a 1. Well, it's not necessary to remove it, but I will so that the pattern emerges. If I remove a 1 from the binomial 2x plus 3, what remains inside is 2x plus 3. So I've now created a common factor here, but instead of the common factor being a single variable or a single number, the common factor is now this binomial term. So I bring the binomial term out and I write it once. And then this binomial term's factoring partner for this particular quadratic will be to bring together the two factors that you removed, 4x plus 1. So the factored form of the original polynomial, we've now discovered the two binomials that were multiplied to create it. And with each of these, always go back and multiply to make sure that you have gotten the correct answer. So 2x times 4x gives me the 8x squared. 2x times 1, and 3 times 4x, and then 3 times 1. And when I add 2x and 12x together, I get 14x, giving me the polynomial that I originally started with. I'm going to run through the same algorithm using a problem on the other side. And I will use the problem on the other side. I am going to do the first problem again. So this would be 6x squared plus 19x plus 15. So it's arranged in the proper order. That's the first thing. Identify the pieces. A is 6, B is 9, C is 15. Find the product of AC, which means I'm going to multiply 6 times 15, and that gives me 90. I now need factors of 90 that sum to give me 19. Well, 9 times 10 is 90, and 9 plus 10 is 19. Now, sometimes this is the part that takes the longest, trying to find factors of the product of AC that actually sum to the linear term B, but you have to put the time in to discover the correct factors, otherwise you get the wrong answer. Now, take the original polynomial, and we're going to rewrite it with 4 terms. We're going to write 19x as the sum of 10x and 9x. Then we come back with the factor by grouping, parentheses. Look at each binomial that you've created with the red parentheses. Remove what is common. So the first pairing, they both share a 3x, leaving behind a 2x plus 3. And the second pairing, they both share a 5, leaving behind a 2x plus 3. Now, I forced a match with 2x plus 3, so I bring that out. And then the other binomial partner would be comprised of the two factors in red, 3x plus 5. And I should have a sign in front of the 5 right here. Something I want to point out, though, when you're going from, and I'll change my other colors, when you're going from this step to the next step, when you're trying to decide what to factor out of the newly created binomials, the whole point is to create the matching binomials that are in blue. So you need to remove the factor that would force a match here, because if you don't force a match, then you really haven't done anything on the way to finding the solution to the problem. So you're removing the factor, and sometimes there's a sign involved as well, meaning a positive sign or a negative sign. But you're trying to force matching factors so that you can then write what's in blue just one time, and then the two factors that you remove that are in red, they come together to create the other binomial factoring partner. And then I check my work by multiplying back. I have 6x squared plus 10x plus 9x plus 15. And when I add 10x and 9x, it gives me the original 19x linear term. So you can see that I've created the correct binomial factors. So always go back and check your answer at the end.